You know, there are these hidden workhorses all around us, running silently in our cars, our homes, our cities, powering basically everything. And today, we're going to pull back the curtain on these incredible machines, pumps.
Okay, just think about that for a second. We're talking about three completely different things, right? One is a life-saving medical device, one makes your car go, and the other delivers the water you drink and use every single day. So what's the one thing that connects them all?
Yep, that's it. Every single one of those systems, as different as they are, relies on a pump to move a fluid, whether that's blood, gasoline, or water. It's this amazing piece of engineering that's literally everywhere, and we're about to figure out exactly how it all works.
Now, you might be thinking, there must be thousands of different kinds of pumps out there, and you'd be right. But here's the cool part. Pretty much every single pump you can imagine falls into one of just two major families. And their whole philosophy on how to move fluid, well, it couldn't be more different.
So take a look at this. This is basically the pump family tree, and you can see that great divide right at the top. On one side, you've got your dynamic pumps. On the other, you have positive displacement pumps. It doesn't matter if it's a tiny pump in your coffee maker or a giant one on an oil rig, it started its journey down one of these two paths.
So what's the big idea that separates them? Well, think of it this way. Positive displacement pumps are like passing buckets in a fire line. They trap a very specific amount of liquid, seal it off, and then shove it out the other side. Methodical. Dynamic pumps, though, they're more like a slingshot. They don't trap the fluid. They grab it, spin it like crazy to get it moving really fast, and then use all that speed to build pressure. It's all about trapping versus slinging.
All right, so let's dig into that first family, the methodical movers. These guys are all about precision, raw power, and consistency. They're kind of the strong, silent types of the pump world.
And here's the key thing to get about them. They move a fixed amount of fluid with every single rotation or stroke. Because of that, their flow rate is incredibly steady. It really doesn't care how much pressure is pushing back, it's just going to keep moving that same little packet of fluid over and over again.
And even within this family, you get a couple of different styles. Over on the left, you've got a rotary gear pump. See how the fluid gets trapped in the teeth of those spinning gears? That's the kind of thing that pushes oil through your car engine. And on the right, that's a reciprocating piston pump. It moves back and forth, kind of like a syringe. If you've ever used a high-powered pressure washer, you've used one of these. They both trap fluid, just in totally different ways.
And check this out. This is a really clever design. This is a vane pump. See those little rectangular blades? As the center part spins, those vanes are pushed outwards against the casing wall. What's so smart about that is as they start to wear down over time, they just slide out a little bit further, automatically closing the gap. This means the pump stays super efficient for way longer because fluid can't slip past.
Okay, but with all that power comes a huge warning. Because these pumps are designed to move a fixed volume no matter what, you absolutely cannot run one if the pipe on the other side is blocked. The pressure will just keep building and building and building until something gives. And that something is usually the pipe bursting or the pump itself getting destroyed. This isn't a suggestion, it's a law of physics for these machines.
All right, let's switch gears and hop over to the other side of the family. If the positive displacement pumps are the strongmen, then the dynamic pumps are definitely the sprinters. Their whole game is about speed and high flow. And I've got to introduce you to the absolute superstar of this family, the centrifugal pump. I mean, these things are everywhere, from your swimming pool filter to the massive systems that supply water to entire cities. And the heart of it all is this thing right here, called an impeller. It's basically a super specialized fan, but for liquid. So how does it do its magic? It's actually a really cool three-step process. First, water gets sucked into the center, the eye of that spinning impeller. Then, the blades on the impeller catch the water and just fling it outwards at an incredible speed. Finally, all that fast-moving water slams into the specially shaped casing, which is called a volute. The volute forces the water to slow down, and all that energy of motion, that kinetic energy, has to go somewhere. It gets converted directly into pressure. Simple as that. And here is the massive safety difference. If you close the valve on a centrifugal pump, the impeller just keeps spinning the water that's already trapped inside the casing. Now, it's not great, it'll heat that water up pretty fast, but it won't keep building pressure until something breaks. It's not going to explode on you. That's a fundamental difference in how you can operate these two types of pumps.
Okay, so we've got our two pump families, each with its own set of strengths and weaknesses. So, how do you know which one to pick? Well, it all comes down to what you're trying to do.
This table really breaks it all down. For instance, if you need to move something really thick and gooey like oil or sludge, you need the brute force of a positive displacement pump. A dynamic pump would just get gummed up. But if you need to move a huge amount of something thin, like water for an entire city, you want the smooth, high flow of a dynamic pump. And of course, there's that big, bold, dangerous warning for the positive displacement pump versus a closed valve. That's a huge factor.
So let's just boil it down. You'd pick a positive displacement pump for jobs that need really high pressure, like in a hydraulic press, or for things that need exact measured amounts of liquid. But if your main goal is just to move a ton of water efficiently and you want something with fewer moving parts that's easier to maintain, the dynamic pump is your winner, hands down. They're both fantastic tools, but they're specialists for different jobs. So next time you turn on your faucet, think about it. That water is almost certainly getting to you thanks to a big, dynamic centrifugal pump. And that hydraulic lift raising a car at the auto shop, that's the unmistakable power of a positive displacement piston pump. They're hiding in plain sight, these unseen machines, but now you know the secret of which family they belong to.